So now that we've discussed how to apply some of these derivative rules to take a function and express it as a derivative for any input value that we want for that function, we're going to look at what that tells us about a real world example. So in this problem, for a particular company, it says the revenue from producing Q units of a product is given by the function R of Q equals 1000 Q minus 3Q squared. So in part A, it says find R of 125. Notice that for this value here, R of 125, that we are plugging 125 into the revenue function, into the original function. So R of 125 would equal 1000 times 125 minus 3 times 125 squared. And if you compute that number using your calculator, you'll get R of 125 equals 78,125. So that is the original function. The original function tells you revenue for some Q items or Q units. So what this number is telling us is the revenue for 125 units is $78,125. If we want to find R prime for part B, R prime of 125, well then we actually need to compute the derivative, R prime of Q, and that will allow us to plug in some number Q. R prime of Q, using our rules, the 1000 Q, the derivative of that would just be 1000, and the minus 3Q squared, the derivative of that would be negative 6Q, or 1000 minus 6Q. So now we can find the derivative for 125 items. R prime of 125 would equal 1000 minus 6 times 125. And in this case, we'll get R prime of 125 equals 250. Now the difference here is this is a rate of change. This isn't telling us the revenue, it's telling us how fast the revenue is increasing for each additional unit. So what this number tells us is at 125 units, revenue is increasing. I know it's increasing because 250 is positive. Revenue is increasing $250 per unit.